All right, good morning, everyone. I'm Mike Park, and I'm here to talk about PoISoned POS, how not to make an iOS mobile point-of-sale application. So who am I? I'm a managing consultant with Trustwave Spider Labs. I have well over 14 years of application development and security experience. I am one of the unlucky people in the room who had to download the JDK 1.0 over a 33.6 dial-up modem back in 1995. Took me 3 times because my wife kept picking up the phone. Obviously then I'm a Java developer mainly, but I've also done a lot of C++, a lot of Objective-C. As part of my job, I do a lot of scripting in Ruby and Python, and I've done some pretty intensive JavaScript development as well. I also do a lot of x86 and ARM version 7 reverse engineering. I play around with the exploit development and stuff, but I usually use my reverse engineering skills for figuring out how things are working in thick client applications and mobile. My specialty at Trustwave Spider Labs, where I'm the manager of application security, is doing mobile testing, and not only just of applications, but I also do testing of platforms in general and MDMs and things like that. So, what's the business problem I'm talking about here? Lines suck. If everybody's ever walked down this back hall, they know how bad lines suck. Right? Here's what happens from a business perspective. Customers who wait in line, they get bored very easily. They'll often be standing there with an armload of stuff and say, I'm sick and tired, and put it down and walk away. You lose sales. People are often in a hurry, and it's a very inefficient use of resources. Everybody go out on Black Friday when you do your Christmas shopping, and you're going to see a situation where you're going to have 3 cash registers open, and they all have tons of lines, and then 7 sales associates standing at the back of the store doing this because they've got nobody to help because they're all up in line. Very inefficient. It's a very bad thing to do. So, what if we could give every employee a cash register instead of just having the 1 or 2 at the front of the store? That would be a great idea. So, that's the problem. What's the technical problem we're going to talk about here? Why not go mobile? How many people have seen this in the store? How many people have seen this at a restaurant? Yeah, absolutely. This was the great idea, right? How does it work? Well, of course, there's going to be less lineups. If I'm getting help by a sales associate, they can stand there and help me out, look up stuff, and as soon as I'm ready, swipe the card, pull it off their belt like the guys at the airport do when you turn in your rental car, and hand it to you right there, and you walk out of the store. That way, you've got lots more information, you've got people being helped, being personalized help, and every single person who works in your store now runs the cash, accepts payments, and you can get a lot more people through your store. It makes a lot of money, and from a business perspective, it makes a lot of sense. Again, we've all seen this. It's very common now, especially like rental cars. It's very common in some retails, lots of restaurants. I can't remember the last time I had to go actually to a cash register to pay at a restaurant. So this is very common. Now you just need to build it. So now let's talk about the security problem that this brings up. According to the Trustwave 2013 Global Security Report, a copy of which you are more than welcome to go to our booth in the far corner and pick up. It's a great read. But retail is the target in 45% of the breaches that our guys investigate. Food and beverage is 24%. Those are the 2 biggest targets for thieves. It makes up close to 70% of the breaches that we're seeing. They are also the 2 main ones that are going to use a mobile point-of-sale device. What are the targets for those thieves? Again, from our Global Security Report. Well, e-commerce site at 48%, 47% of the time, they're going after point-of-sale devices. Right? What does that mean? That means that more registers means more points of attack. Your attack surface just got bigger. Also, because these things don't work with cash itself, they work with credit and debit cards, that you're going to see the guys going after them because that's where the money is. This isn't an actual credit card. This is my Tim Hortons coffee card, but it works basically the same way. This thing The numbers on here, especially if it's raw PAN data, is gold to the thieves. That's why they're attacking this stuff, okay? Because point of sale is already a major target, this is just a different form factor from when the bad guys are going after. This is the same thing as the big point of sales that they always are hacking, that we investigate on an ongoing basis. So let's talk about the case study, okay? The poison POS sort of thing I'm going to talk about is based on a number of different penetration tests that myself and my team conducted at Spider Labs over the last 2 years. That being said, most of this stuff comes from a single case study, a single penetration test that I did that had me so blown over that people were still doing this that I had to make a case study out of it. I had to use it in a set of slides. I had to come up here and speak to people about it, because if I'm seeing it in 2013, the kind of stuff I'm going to talk about on penetration tests that people are paying us for, what are the guys out there who aren't paying us, who are going to different vendors or aren't getting penetration tests done on their devices? What are they going out and doing, right? Now, again, no one app had all the issues, but I'm going to mainly be speaking about one test that had just about every issue. Now, of course, the names will be changed or not mentioned to protect the innocent, and also to prevent my Canadian ass from being sued. Again, so please don't ask me. And I'm also not going to mention the maker of the card reader that will be part of the focus here, mainly because the card reader itself is not the issue. It was how it was being used by the developers of the mobile point-of-sale application. And that was the big issue. So what did they all have in common? They all had a mag stripe reader that allowed you to accept payments. They allowed employees to log in, identify themselves, take the orders, and then they would store order information on the device. I see eyebrows already being raised. That's good. They would either then sync it in real time with a back-end system, or as a feature, because if your back-end system was down or your store Wi-Fi was off for a reason, you know, like it was yesterday here at the hotel for 3 hours, then it would allow you to still run transactions, do store and forward, and things like that. They were almost all created fast in order to get to market first. They need to be done as cheap as possible and pushed out to hundreds of locations. And because we're talking about retailers, they had to be on cool little trendy iOS devices so that you could look trendy at your store. Think about that, and then ask yourself, what could possibly go wrong? So let's have a quick overview of poison. Here's the typical workflow of the POS application, right? We already talked about it. Employee's going to pick it up. They're going to log in. They're going to take the order information. They're going to start running transaction. They're going to accept the credit card data, and then they're going to complete the transaction. That's the entirety. It sounds like a simple thing to do, right? Serious flaws exist at each one of these steps if you make bad choices. And what this is really about is a series of bad choices that a couple of our tests and a couple of our clients made when creating these point-of-sale applications. And each one of those led to even worse choices down the road. Now, some do require a jailbreak. But, and I'll point them out when I talk about them, a lot of them didn't require a jailbreak. You can get files off an iOS device using a tool like iFunbox, or you could script it yourself using libUSBmux, and you will get a hold of this information. No jailbreak required. So let's talk about jailbreaks just for a quick minute. Originally for this, I was going to jailbreak a device and show you how to do this. Unfortunately, iOS 7 does not have a publicly available jailbreak, which means I can't restore this to iOS 6 and jailbreak it for you, because they'll make me upgrade to iOS 7 and then I'll be screwed. So unfortunately, I don't have my demo, but I think the code and stuff that I've got in here will demonstrate the issue pretty satisfactorily. Now, that being said, I don't want you to sit there and go, oh, iOS 7 is not jailbroken, so I don't have to worry about it. Actually, iOS 7 is jailbroken on iPhone 4 devices. It's not a publicly available jailbreak, but it's also not a dirty secret, and there's lots of places you can go to find out how to do it. It just, if you're technically savvy, it just takes a few different steps, okay? There's also jailbreaks for iOS 7 that we know people have them, right? But they're just not releasing them to the public. An iOS 7 exploit is worth a lot of money, and who's going to have the money to do this? You're going to find organized crime who wants to break into point-of-sale systems and steal credit card data. They're the guys who are going to get a hold of this, right? Never assume that the bad guys don't have this. Oh, but Apple doesn't get malware. Well, see above. This kind of attack is not going to be like you see on Android, where they download a rogue application, the rogue application then gets access to your system. This is going to be a targeted attack. The bad guys are going to look at your store and say, hey, you've got a mobile point of sale, it's based on iOS, I am now going to be able to attack you because I'm going to write targeted malware. And shockingly, and you'll see from the code later on, the targeted malware, 25 lines of code, it's not very much at all. I also want you people to understand that a jailbreak is simply a public term for a local root exploit. Now, you would never assume that just because you don't know about a local root exploit on Windows XP or Windows 7, that one does not exist, right? There are jailbreaks out there for iOS 7, so don't assume simply because it's not public that there isn't one there. And I can almost guarantee that within the next 3 months, there will be one released by the guys at Evasion and that for iOS 7. So let's look at our first issue, the poison login. This was the login screen. No password required. Biggest assumption that the developers made was this device will never be in the hands of anybody but an employee. Not a great assumption to make. Right? All the employee had to do was put in their 4-digit employee ID. And then they were in. The best part was, because they had the feature of working in an offline mode, in case the Wi-Fi was down in the store, they stored all the employee IDs for every employee on every device. Right? Again, I don't need the jailbreak to get this information. I simply need to plug it into iFunbox or script something up in libUSBMux and pull it off. It uses the same protocol that iTunes does to pull stuff on and off your device. Also, it's 4 digits. How long is that going to take? I can do that in 20 minutes on the device. If I pull it off, I can do it, it's not going to take very long to do it. The database was not encrypted. It was wide open. And here's some of the examples. Every single employee. So, what does that mean as an attacker? Well, one of the things I could do would be to get a hold of it, put in an employee's number, and then start running fake transactions through on stolen credit cards, and then I'm stealing your stuff. I have the employee IDs, and this is I'm just showing you the IDs. The rest of the thing had their phone number, it was like an HR table. It was horrible. The other thing they were doing was storing the iPod's device ID, because as part of the login, when they did connect to a back-end system, was they wanted to say that this transaction was run by this device. And what did they use to identify this device? They used the IMID. What else could you use an IMID for? Let me think. Again, because they wanted to be in offline mode, and for some reason I couldn't figure out that you could actually read the IMID off the actual device you were on, they decided to store this information for every single device that they had in service on every single device that they had in service. So guess what I can do? If I get a hold of this stuff, I can now, using a legitimate Apple developer account, which are up for sale in some of the blacker markets out there, legitimate accounts. And I can go in and I can create malware, or I can create custom applications, and they will install on your device because I'll simply say, oh, you're one of my test devices. Here's my ad hoc. Go ahead. And it'll get installed on your device without you being told that it's not an Apple thing. This was how FinFisher worked. If you've ever seen a reverse engineering about FinFisher, they went and had a look and said, here's all the stuff it can do. Oh, by the way, here's how it works and how they'll get it on your device. So let's talk about some of the transactions, right? You get presented with a screen, you put all the information in, they can select the items. What they did was, because they were doing store and forward, and they said, this device will never be in the hands of anybody but an employee, they would store all that information on and then upload it to their back-end server, where it will be processed by the back-end server. What could I do? Well, number one, I could intercept this because it was very easy to man in the middle, and we could change it. I was actually able to give myself, it's a little hard to see here, but I purchased something for $7 and put myself a $10 discount amount. And we sent it to the back-end server. And this was what I got back in the email. It said, yeah, your payment's pending, your total price was $7, but we'll give you a $10 discount. The attack here is, I have now broken into your system, I've run a transaction, I've given myself an arbitrary discount, so not only do I get the goods you just sold me, but you're also going to give me $3 on top of it, because you're so nice. This is very common in a lot of mobile applications, but for a point-of-sale application to do basically what we call trusting user-supplied data in order to make pricing decisions was ridiculous. So here's the big one. Let's talk about how PiOSoned did credit card acceptance. Swipe your card, type the card number in, yeah, and then encrypt it with a public key for the back-end server, so that only the back-end server's private key could decrypt that credit card information and send it on to a processor. I see more eyebrows being raised. Yes, this does require a jailbreak, but the code to do it is literally 25 lines of code long. They had a screen in here when I first tested it that was, type in your credit card number, your CVV, your expiry date, in case the card reader didn't work, or in case someone else had the card reader. I then talked to them about, well, that's dumb because all I did was find the encrypt function and I hooked the encrypt function. And because I know that's the one spot in the application where the credit card data is coming in unencrypted because you're about to encrypt it. And I can grab it there. The other part was they actually had, and this was their first bad choice, they chose to go cheap. They chose to get a card reader, and I won't identify the brand. They chose a card reader that was really, really cheap and was fully capable of encrypting at the head. But after they chose the card reader, they discovered that in order to make it encrypt, you actually had to take it out and put it into an HSM. So instead of just having card readers out there, they had to have card readers and HSMs in each one of their retail locations. All of a sudden, their cheap card reader wasn't so cheap. But of course, they need to get it out fast. So what do? We'll encrypt in software. The attack here goes something like this. Now, by the way, just so you know, talking about jailbreaks, which one of these is jailbroken? Yeah, exactly. Both of them are. Smart move. Everybody, yeah. I can't trick you guys. You can't tell. I mean, the regular jailbreakers, the Cydia guys, they make it obvious that you've jailbroken because they put the nice Cydia icon in there and they let you know. And part of the reason that they develop their jailbreaks is in order to let you tweak the UI and all do the fun stuff that Apple doesn't let you do. We've actually done this in previous years. We've weaponized that so that it'll jailbreak without doing any of that. You can't tell by looking at your device if it's been jailbroken or not. And I can't tell, and Jason Haddix can't tell, and Art Dannert can't tell, and none of the other guys that are in this room can tell, and you're technically savvy. Think about the store associate whose main job is to sell you shoes, are they going to know if it's jailbroken? Of course they're not. So, the attack is, you get a hold of this, you jailbreak it, you put it back in service. Jailbreaking takes about 10 minutes. If you've already got your malware on there, it's literally another minute to install the malware, and then you just put it right back in service. Think of a big box store, think of some retailer that you go to a lot, and think how easy it would be to do this, because often you'll see them sitting behind a cache in their cradle recharging. Also, they all look identical. iPods look the same. All I need to do is lock one that I own, take it in, replace, go jailbreak. Someone comes to pick this up and goes, someone locked it, I'll take the next one in the cradle. Then I come back and switch it out. Now I've got a device sitting in there that's accepting credit cards, and I've hooked it so that I'm stealing the credit card data as it comes in. Again, jailbreak in about 10 minutes, install in under 2 minutes. From the time of me grabbing one of those to the time of me getting it back in service, 15 minutes tops. If I get really good at it, it'll be even faster. If I decide I'm going to create a device that just plugs in and automatically jailbreaks and plugs it back out, it'll be even faster. So how did I do this? So basically I get a hold of the binary. I run a tool called class_dump_z on it. If anybody knows the Mako format, it pretty much tells you everything. No, there's no such thing really as an export table. Anything that's in there is automatically exported. So I just did a class_dump_z and I went looking for something interesting, and I went, oh, look at this. Encrypt credit card with public key tag. I'll bet you that's a good one to hook. So I did. Except for the imports up here, this is the code. That's it. There is a macro for this, for the hook. That's probably another line and a half of code. And it's freely available out there. This is based on some work that Eric Monty, who used to work for us a couple years ago, he and I worked on a similar project to this, where the client actually ended up doing the same thing, but that client did not have the luxury of having credit card readers that encrypted at the head. At the time they did theirs, they had no choice. So we did this for them, show them what was possible, and they put a lot of other mitigating factors around their solution. And immediately when credit card mag swipe readers that were encrypting at the head came available, they switched. But this is it. This is the code. I'm just doing the hook, good old method swizzle. For those of you who know what that is, in Objective-C, you have an implementation, or an interface and implementation. Method swizzle is actually a feature of Objective-C, and it allows you to swap the implementation of a function out at runtime. It's like reflection in Java. You're able to do it really fast. And so what I did is I swapped out the original implementation with my implementation, and then I went back to the original. Now, for the sake of point of proof of concept, all I was doing was writing this stuff out into the logs. I could have done things like, and here's the actual evidence screenshot. I'm hooking. There's my card number. I could have grabbed the PAN data if I'd gotten a different, right? There's all sorts of places. Now, I could have exfiltrated by grabbing the device again, which would have been a little more risky, but I could have I've got root access to a device. I could have used GameKit. I could have used Bluetooth. I could have grabbed the Wi-Fi. I could steal the device back. The one assumption that the guys who designed this, who came up with this idea, didn't think of was the malicious insider. It's like everyone in this room imagining that the only danger to your application is a kid in their basement somewhere, when in fact it may be the person sitting in the cubicle next to you. In fact, about 80% of the attacks we see actually come from insiders, not from, your typical black hat guys on the outside. So, the other bad idea they came up with Let's pretend that they didn't do something silly like that and did have a card reader encrypting at the head. The other bad idea they come up with was the feature that says if the card reader doesn't work or the card is demagnetized and you can't run it through the stripe, you can type it in by hand. It's also signed with a certificate that's installed on the device. Right? The one smart move that this particular client did was we're going to use public key encryption to do the encryption. So we're going to have the server's public key on the device. We're going to encrypt the credit card data with that so that only the server can decrypt it. Of course, they stored it on the device. That's like storing the key with the lock. One of the attacks that we came up with was we go into the keychain, we find that public key, we replace it with our own public key, and now it gets signed, and now I have the key to decrypt it, and actually the other guys don't. One of the dangers of running this in offline mode. This is an actual screenshot from my evidence for this particular test. Not only could I do this, this actually occurred when you did the old put it in and then let your device go to sleep. iOS took the screenshot for me. I could have had my malware that said anytime this screen comes up, start taking screenshots. And then I would have had this sitting there. And the beauty of it is, because it's an image, you can scan it all you want. You're not going to see credit card numbers inside the image. But a human looking at it can see the credit card numbers very, very easily. So what's the antidote to all this? Never, 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 never encrypt credit card data in software. Ever. If you are ever in a position where you need to create a mobile point of sale for any platform, but especially for something like iOS, don't ever encrypt your credit card data in software. It's easy to hook. It's easy to jailbreak. Right now everybody's going iOS 7. 3 months from now, when the iOS 7 jailbreak is public, then there'll be a situation where it's easy to do. Make better choices in your design. One of the big issues that sort of cascaded here was the first bad choice these guys made. They picked the cheapest card reader out there without investigating anything about key management. Right? The cheapest card reader off the top that maybe cost $50 for a reader suddenly was going to end up costing them $150 per device because they needed to have a hardware HSM in order to roll keys, or they couldn't roll the keys. I have done a test for another client, and this client actually had it the right way. They spent a little bit more money up front, and they bought a card reader that actually let you do the key management OTA, and they were able to roll keys and do it over the air without requiring an HSM. They could centrally manage it. It was a slightly more expensive off the top, but they didn't have any of the issues. Because these guys picked this one and then realized afterward that they couldn't, it was going to be hard to encrypt using the hardware, that's when they started making the choice of, okay, we're going to encrypt in software. And as soon as they made that, it cascaded to all the other bad choices that they made. There are no card readers on the market right now that are not capable of encrypting at the head. But your choices could be ones that encrypt by default and ones that don't encrypt by default. And don't pick the one that doesn't encrypt by default, and pick the one where you know the key management beforehand. Yeah, better authentication and storage. I still was not able to figure out why they were storing all the IMIDs and stuff on the device. Never store passwords. I mean, I shouldn't have to say this in a room like this, but never store passwords in plain text. Actually try to have password. Oh, and by the way, in case anyone didn't notice on that one slide, they were actually using basic authentication to the back-end server as well. They encrypted the credit card really well, but they decided that basic auth going to the back-end server was a good idea because it's base 64 encrypted, right? They didn't have any of the data protection API usage on any of their files. If they had simply encrypted those SQLite databases, despite all the bad choices they made, if they simply had those encrypted, I couldn't have pulled them off and looked at the data. But they didn't. They didn't have them marked with any of the data protection APIs at all, which means I would have had to know the password for the device. They didn't have any of that. I would recommend that you not only use PBKDF2 for the application, and you also have not only the SQLite database encrypted, but you have the information in the rows encrypted as well. Sign all the transactions. They're already using public key cryptography for encrypting credit card numbers, but they didn't bother to actually do a digital signature on the transaction to know if it had been changed in transit. And I was able to get great big discounts. I was able to do all sorts of information stealing like that. They also didn't do SSL pinning. One of the things that really would have kiboshed me is if they actually had done SSL pinning. This is a point-of-sale application accepting credit cards, and you're sending it over the network. If there's any application out there that requires you to do something like SSL pinning, this is the one. Who knows what SSL pinning is? Who doesn't know what SSL pinning is? SSL pinning is where instead of trusting the 144 root CAs on your device by default, you set up your SSL connection to say, I'm going to only trust this certificate from this server, and I'm going to verify the entire certificate chain when I do it to make sure that it's only this root CA that I trust. And that way, I can't do something like what I did for this, which was get my port swigger cert, email it to the device, and then how easy it is on iOS to install a root CA. Email, press a button, accept, now it's trusted on the device. And any transaction signed by that particular root CA will be trusted by every application on the device. That's how easy it is. There's a little social engineering involved in the attack, but not much. The other thing I'd like to point out is offline mode really needed? Right? I had two issues with this attack when I was sending user supply data and altering the transactions and giving myself great big discounts and making it so that you ended up paying me instead of me paying you for stuff, was I was intercepting it over SSL, but I didn't have to do that. I could have pulled the database where they were storing all their transactions off the device, changed it in the database, and put the database back on. And then it would have sent it up. And they would have trusted it. Do you really need to do something like this in offline mode? Business decision, but from a security standpoint, probably running a point of sale in offline mode is not a good idea. So, one of the antidotes, and I say this when I do secure development training in general, but one of the things especially when you're talking about point of sale, assume your software will run on a compromised device. Right? The assumption that they kept making that, oh, it's only going to be in the hands of a store employee. Oh, it's never going to leave our store. It's only going to be on our internal network. It's an internal thing. We don't have to worry about it. No. Right? Assume your software will run on a compromised device. Shannon's maxim, the attacker knows the system. Assume your software is going to run in the worst possible environment that it can run. And then start coding so that it'll either run safely in that environment or it won't run at all. It'll fail closed. Assume your channel is going to be listened in on. One of the big assumptions these guys made is it's our internal network. No one will listen on it. Yeah, how many people here have ever done an internal network penetration test? Yeah, exactly. How safe is that, right? Oh, no one will listen in on our internal network. It was very easy to man in the middle of this. So we were looking at data, but we were also altering data. Assume the device will be easily obtained by an attacker. Obviously, no threat modeling was done when they designed this system. They assumed for some reason that this device designed for portability was not portable enough for someone else besides an employee to pick up. They also did not consider the insider threat. Like I had said, somewhere in the neighborhood of about 80% of the stuff we investigate, and 80% of the attacks that are out there are actually conducted by insiders. And the insider could be a store employee, it could be the person who cleans the store, it could be the person who owns the store next door, right? When you have a person whose information has just been leaked to the local organized crime gang because they were able to pull the database of everybody's username, password, and phone number off a single device for every device that was out there, and you get approached and you're making just above minimum wage selling shoes at a store, and someone comes up to you and says, hey, we're going to give you X hundreds of thousands of dollars. All you need to do is go into the office or go into the store before it opens and do these 5 steps, boom, 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 and install our stuff on there, and then just work like normal. And we'll give you a cut. I think that would be a very plausible attack. I'm shocked it probably hasn't already happened. All right? It's just a bad idea all around. Assume your attacker can get physical access to the device. Cheaper is not better. I've already said it. They went for the cheapest device, not realizing that one of the reasons it's so cheap is because it doesn't encrypt by default, and in order to get it to encrypt, you have to invest in a lot more infrastructure than you're prepared to invest in. Right? Spending a little bit more up front actually ends up saving you a lot more in the end. Choose your card readers wisely. Some of the other mitigating controls you may want to choose to put around here is using an MDM to lock the device down. A lot of the devices that we were testing in the field for this, I still had complete access to email. I had complete access to the system menu. I could have installed any old profile on it. It was unbelievably bad. Ironically, it was one of the things that the very first test we did like this that occurred a couple of years ago when they didn't have card readers that encrypted at the head, it was one of the things they did. They turned around and had an MDM solution. Their MDM solution locked it down so that if you did have physical access to the device, you couldn't go in and change things. You had to do it all through the MDM. The other thing they did was restrict access to the network. They restricted access by saying, and they had their MDM listing on the internet. If this ever came outside of their network and turned on, their MDM would communicate, and their MDM listened on internal and external. And if this device ever communicated to their MDM on the external network, it got wiped. If it ever connected to any other network but the in-store network, and I mean the store it was in, you couldn't even take this device from one store to the other, which was also a possible attack we looked into. If they took this device and put it on any other network but the store it was in, the device would automatically get wiped the next time it turned on. Right? It's not a perfect solution. There are ways around it. You know, you can block networks, block ports, block commands to wipe. But it took the attack surface and it took the time that an attack could be successful from days and months and weeks to literally to hours. You might get away with a couple of swipes before it wiped. One of the things we recommended them to do, especially considering they had to encrypt in hardware, is, use it during the day and then wipe and restore every night. A little over the top, but I guarantee you, if they got infected with malware that was stealing credit cards, it would wipe them and it would reduce the risk because, okay, yeah, they're gonna get a couple of $100s worth of purchases, or they're gonna grab maybe 5 or 10 credit cards, but that's it. Wipe and restore. Again, anything that reduces the opportunity for the attacker to carry out an attack or that reduces the amount of time the attack can be successful is what you want to do. One of the other things we kind of recommended and kind of looked in when Jonathan Zdarsky's book came out was using his idea of location-based encryption. Right? The information on the device can't be read unless you're actually at the location of the store. If you go anywhere else out, it's totally encrypted and you can't get at it. All right. Short and sweet. Thank you very much. If anyone has any questions, feel free to ask. And I'll let you go. Thank you.